In this lecture, we are going to cover the horizontal movement of the player. But before we start doing anything, we need to set up the input. Let's go to Edit, Project Settings. Then we scroll down to the Input under the Engine section. You'll notice there's some sort of warning message that says this is deprecated, and it says you should use the enhanced input system instead. But personally, I don't really think it's a good idea to start this beginner course with the enhanced input system, because the enhanced system was just recently created for games that have complicated input systems. For example, people might use different input devices when playing the same game. So you want an easy way to manage the input mapping for different game controllers, keyboards. What the input mapping is really complicated in your game. You have so many buttons for so many different actions. You want a way to keep the input mapping organized, and people also might want to remap the actions to different keys. See, these are pretty complicated situations for really big games. The enhanced system is going to cover that, but it also takes a lot of time and effort to set up the system. Since this course is for beginners who do not have a lot of experience with engine, and the input action of our game is not complicated. That's why I think we should stick with the default input system here. It's easy to use, it does not take a lot of time to set up. In the future, when you are comfortable with the engine and you have finished a few small projects, then you decide to move on to start a more complicated game, I think that would be the right time for you to get to know the enhanced input system. All right, for now, we just need to cover the keys that move the player left and right, and the key for the jump action. First, let's add an axis mapping. Let's call it move right. Expand it, then let's add the D key from the keyboard. The scale value to the right should be 1, because when the D key is pressed, we want the player to move to the right. We also want to add the right key for the same movement. The scale value should also be 1. Next, we are going to add the keys for the opposite direction. So let's add the A key from the keyboard. We need to change the scale to -1, because the player should move to the left when this key is pressed. We also add the left key. Also change the scale to -1. Next, go up to the action mappings. Press the plus button and change the name to jump. Then let's add the space key to the jump action. Alright, this is pretty much all we need for here. We can close this project settings window and go to our BP player. I already have the BP player open, so I can just click on the tab here. If you don't, you can press Ctrl plus the space key to bring up the content drawer. You can open the BP player under the BP folder. Alright, first, let's go through the 3 tabs up here. You can see the visual of the components in the viewport. I think you already know this. And the construction script. Whatever you put in the construction script only happens once when the current blueprint is created in the game. So this is the place where we do some initialization operations. You can set the default value for some variables here, or do whatever you want to prepare the current blueprint to do its job. I think in our course, we are most likely not going to do anything here. So let's skip the construction script and move on to the event graph. This event graph is where we are going to do the visual scripting pretty much most of the time in this course. So basically, we are going to add some nodes here that have different functions, and we connect them to create the control flow. So the engine knows how to execute the nodes. You can see here we have 3 default events here. The begin play event only happens once when the current blueprint starts to function in the game world. The actor begin overlap event happens when the collision shape of this blueprint intersects with other objects. And the event tick happens every frame when the game runs. This is where we do the things that we want to repeat, basically every frame of the gameplay. I'm going to show you how to use these events later on. We do not need these events for now. Let's just get the input data and make the player move. We can right-click and search for input, move right. This is the move right we just created. We select this one under the axis events. You can see there is an arrow icon before the name. You can also see the icon in the node. This icon tells us that this node is an event node, which means this node is going to be triggered by an event. In this case, the event is going to be triggered when any of the keys we just defined are pressed. So whenever we press the A key or the D key or the left or right key, this event is going to happen. To move the character, we can search for a node called add movement input. We can see a letter F in front of it, which means this is a function node. So the idea is very similar to the function that we would use in a programming language. All right, let me go through the input of this node. The target is the thing that we want to move. We can see the target now is self. Self means this blueprint, or you can think of the rule node of the current blueprint. So this blueprint is a paper character which inherits from the character blueprint class. We can see the type of the class on the root, and this function is going to move our character. We want the player to move to the right. So for the world direction, we are going to set the x value to 1. Be aware that this is a unit vector, so it only represents the direction of the movement. Next is the scale value. This is how much we want the character to move along the direction. We are going to use the axis value as the scale value. We can drag it and connect it to the scale value. If the A key or the left key is pressed, the axis value is going to be -1. That is going to move the character to the opposite direction. We also need to connect the input event to the add movement input node. This creates the control flow. So the engine is going to execute from the event to the add movement input node. And without the control flow, nothing is going to happen. We can also arrange the nodes to make things look tidy. You can select the nodes, then press the Q key. You can also hold the Shift key, then press the W key. This is going to align the nodes along the top side. And for Shift plus the S key, it's going to align the nodes on the bottom. Now we only have 2 nodes, but things are going to get messy very quickly as we add more nodes. So these hotkeys are going to be quite useful. Let me compile the blueprint and go back to the level to run the game. After we start the game, you might also need to click on the viewport once to activate it, so it can receive the input from your keyboard. As you can see here, I can move the player back and forth. Now the player moves too fast. Let's go back to the blueprint. We're going to decrease the speed a little bit. Select the root. Then we can search for speed. Let's try 260. By the way, the speed property is actually in the character movement component down here. You can find it in the character movement walking section. To run the game to test, we actually don't need to go to the level. We can press Alt plus P to do it here. You can also see the play button at the top of the window. But when you are running the game in this mode, you cannot press F8 to detach. That's one of the differences here. Alright, now I think the speed is pretty good. Go back to the add movement input node. There's one more thing I want to talk about. If you have some experience with other game engines, you might realize that whenever we move the character, we want to smooth the movement with the delta time. The delta time is the very short time period between 2 frames. Sometimes the frame rate could fluctuate a little bit due to the performance of the hardware, and the delta time will change in this case. So we always multiply the movement by the delta time to make the distance that we move consistent. So that's just a part of the job that we need to take care of. But you do not see the delta time here, right? This is because the add movement input function takes the delta time into account internally, so the delta time doesn't show up here. This is very convenient, but a lot of times we still need to use the delta time in the Unreal Engine here. I'm going to talk about that in detail later on. Back to our player. For now, the player is just a still sprite. So let's take care of the animations. I'm going to open the content browser. We already have the flipbook for the idle animation here. Let's work on the flipbook for the run animation. I'm going to create a folder called player run under the player folder. Then we can right-click on the player run file. Sprite actions. Then select extract sprites. Switch the extraction method to grid. Let's divide the width by 9, since we have 9 frames here. Alright, let's move the new files to the player run folder. Then go into the folder and select all the sprites. Right-click and create flipbook. That's it. Let's save the files and go back to BP Player. We want to update the flipbook when the player's velocity changes. So we need to check the velocity every frame, which means we need to do this in the event tick, since this event happens every frame. Let's select the sprite component. And we can see the source flipbook. This is what we want to change. We can drag the sprite component into the graph. Then we drag from here to call a function on it. The function's name is setFlipbook. Then we connect the event tick to this function. So this setFlipbook function is going to be executed every frame. For the new flipbook, we want to select between idle and run. An easy way to do this is to drag out from the new flipbook. Then we search for select. Then we get the select mode. The convenient thing is that the type of the two options is flipbook, since we dragged out from the new flipbook, so the engine knows the type of the options that we want to select from. Let's change the index to Boolean. For the false option, we select the player idle flipbook. For the true option, we select the player run flipbook. Next, we need to know the velocity of the player. Let's search for the getVelocity function. This function is going to tell us how fast the character is moving. The return value is a vector 3. It gives us 3 numbers along the 3 axes. Since we only need to know the velocity along the x-axis, we need to drag this out and break vector. Let's jump over to the 2D view of the level. You can see x is the horizontal direction and z is the vertical direction of our game, because we do not care about the direction of the velocity. So let's get the absolute value of x, which is how much the character is moving along the x-axis. And we are going to check if this value is bigger than 0. So we can use the greater function to do it. I'm going to check if the absolute value of x is bigger than 0.00001. And then we connect the result to the index input of the select node. Alright, to recap, we check if the horizontal velocity of the player is bigger than a very small number that's close to 0. And if it's bigger, we play the run animation. If it's not, means the player is not moving. Then we play the idle animation. Alright, let's compile the blueprint and test the game. Now when the player is not moving, the idle animation is playing. Then the run animation takes place when we move. This is great. Next, we need to make the player face left when we are moving toward the left. Before we do that, I want to tidy up the graph. I'm going to select all of the nodes we just added. Make sure don't miss out any one of them, since they are all connected. Then we can right-click and select Collapse Nodes. This is going to collapse all of the nodes into a single node. Let's call it Update Flipbook. The event graph can get very messy as we add more nodes. So it's a good habit to always try to keep things organized. If you want to edit the nodes inside, you can double-click on it. Now I want to get out this Update Flipbook and go back to the event graph. But I made a mistake and closed the tab. To reopen the event graph, you can just click here on the left. The right way to go back to the event graph is to click the event graph up here. Also, if you want to reopen the construction script, you can click here. All right, let's go back to the event graph. Let me show you how to rotate the character. To do this, we actually don't need to add any nodes. Let's select the character movement component. Then search for rotation. Let's enable orient rotation to movement. Now the character is going to automatically rotate to the direction that it's moving. But when we test the game, nothing is going to happen because there is another option we need to change. This time we need to select the root. We're still searching for the rotation keyword in the details panel. You can see in the bottom we have a few new options. These are the properties of the character class. Let's disable use controller rotation yaw and enable use controller rotation roll. And the rotation rate up here controls how fast the character rotates. Alright, let's test the game. This really makes me dizzy, and the character is still always facing right. It's very hard to tell what is going on here. So we need to detach from the player controller and check out in the 3D world. We cannot detach here, so let's go back to the level and play the game here. Then let me try to change direction slowly. Then we press F8 to detach. Go to the perspective view. We can see the player is actually rotated, but the arm for the camera is also rotated along with it. Which means no matter how much the player rotates, in the camera view, the player is always facing right. Alright, let's go back to the left view and stop the game. Fortunately, there is an easy way to stop the arm rotating with the player. Let's select the arm and go to Transform. Let's click on Rotation. We can change it from relative to world. This is going to lock the rotation of the camera arm. Then let's test the game again. Now it's very close to the result we want. The player is rotating back and forth, and depending on your personal preference, this might be the effect you want. For me, I don't want to see the rotating process. I want the sprite to change direction instantly. Let's select the character movement component. Then search for rotation again. We can change the rotation rate to make the player rotate faster. And it says a negative value is going to make the process instant. So let's change the z value to -1. Compile and play the game. Alright, this looks pretty good. But for now, the player can step on 2 blocks. And I don't think it's a good idea, so let's fix it. Let's go back to the player blueprint. Make sure the character movement component is selected. Let's go down until we find character movement walking. Let's change the max step height. Let's decrease it to 20. Then let's test the game. The player can still step on 1 block, but it cannot step on 2 blocks, which is what I want. Alright, before we wrap up, there are 2 important things I'd like to mention. First, there is a chance that you are going to see very small gaps between the tiles of the platform when the character is moving around. Luckily, it's not happening when I'm recording this video, but it did happen when I prototyped this project. So I think it's going to be quite common for you to encounter this problem. And let me show you the solution. Let's bring up the content drawer. Right-click on the tileset file. Then select Condition Tile Sheet Texture. You can also read the information here. It says it's going to duplicate the edges to add a buffer zone for each tile. Alright, now we have a new texture file, and we don't need to change its name. This file is already used by the tile set, so we just need to save the changes. Then let me open this file. And let me zoom in. You should see the buffer zone around the tiles. And the gaps in the platform should be gone. That's it, I'll just close this window. The second thing is that you should see some tearing when you run the game in the editor. To fix it, let's go to Edit, then select Editor Preference. Go search for VSync. then we can enable vsync in the editor. And this is going to remove the tearing. All right, that's all for this lecture. Let's wrap up.